All right, guys. So test 2. Remember, it's all over chapter 10. So 10:1 through 10:6. And just like on the previous one, I will break down what questions go for what sections for you. Okay? So that way you know when and where to look at different things. So question number 1. So question 1 through 7. This is all 10.1. 1 through 7 is all 10.1, and this is all about those verifying those identities, okay? Verifying those identities that we have. And we're going to keep this pretty basic on the verifying identities. We're not going to throw anything real crazy at you, okay? So I know sometimes we had some problems in class that were a little bit nutso. This is going to be a little bit easier. So up here, we want to write this as either a constant, which means a number, a single trig function, or a power of a trig function. So in other words, we want this as one trig function, or it needs to come out to a number. So what can I do with cotangent and sine to start doing this, to start changing it around? Change cotangent to cosine over sine. Absolutely. One of our techniques is change everybody to sines and cosines. And you can see on this, it's also multiple choice for this question, I believe, as well, too. Yes? No. Joking. So you're filling in the blank. But some of the other ones will be multiple choice. So you said change cotangent to what over what? Cosine over sine. And then we still have sine x over here, correct? Yes. Good. I'm glad you agree. So what now? Sines cancel out, right? So that leaves us with what? There's your answer. Because there's nothing else to do. That is our simplified answer. Cool? Yes. Good. I'm glad you agree. Moving on. All right. So again, just another one of those questions. Again, single trig function, power of a trig function, or it comes out to be a constant number. So what can we do to this? Change cotangent to 1 over tangent. Absolutely. We can do that. So we got tangent beta on top. Cotangent becomes 1 over tangent beta. Yeah, because we don't divide by fractions, we multiply by the reciprocal. So this looks like tangent beta times, what's the reciprocal of 1 over tangent? Tangent. So what do we get when we take tangent beta times tangent beta? Tangent 2 beta, tangent squared beta. Okay? And down below you can see this one as a multiple choice. That was one of our answers. Okay? Another way to do this, if you wanted to change these into sines and cosines from the very beginning, you could have done that. And you would have ended up with, before the tangent squared part, sine squared beta over cosine squared beta. And sine over cosine is tangent. So you could have also changed these to sines and cosines as well. All right. So again, single trig function or a power of a trig function. Notice it does not say anything about a constant this time. Although it looks like in our multiple choice answers, it could be a constant. So poorly worded directions, but that's all right. So is there anything we know about secant squared x minus tangent squared x? Say it again. There's an identity, right, that deals with secant squared and tangent squared. Do you remember what that identity is? Tangents, oops, almost forgot the n. So you said tangent squared x, what? So how can I take this trig identity here and make it look like this information that's up there? Because it's really, really close to it. Well, we could do that, or, yeah, easy. Pick this guy up, move it to the other side. So how do I get rid of a plus tangent squared? Subtract tangent squared. You could have moved the secant, and then you would have had to move the 1, and then you would have had to flip all the signs in the end. So 1 equals secant squared x minus tangent squared x. So what happens to this answer in the end? It's going to be 1. Because we just shown that secant squared minus tangent squared is 1. Okay? Any questions on this one? Everyone good? See, like I said, we're not trying to throw extremely hard problems at you here. We're going to keep this verifying relatively low-key. All right, so this one, it says express in terms of sine and cosine and simplify. Nothing more than that. Your answer has to be in terms of sines and cosines, no one else. So what do we know about 1 minus sine squared alpha? There's an identity, right? We know about sine and cosine. What is our identity we know about sine and cosine? And I'm just going to keep it alpha since we have alpha here, but there's nothing wrong with using theta. And so if I get the sine to the other side, like what we did with the tangent in the previous one, how do I move a positive sine squared alpha? So we found that cosine squared alpha equals 1 minus sine squared alpha, right? So does that help us simplify this? What is our answer? There you go. This is just cosine squared alpha. So we don't necessarily have to have the sine in there, but we just found out that it's just cosine squared alpha. Cool beans? Because that's what they wanted. And technically, according to those directions, this is an answer, because it is in terms of sines and cosines. But they really wanted you to convert it to the cosine squared. Okay? All right. Numero 5. Again, take this in terms of sines and cosines and simplify it. They do not want any quotients, which means there should be no division in the end. Okay? So, what are some things we could do? What are some things we know? Okay. So there's one idea. This secant is 1 over cosine, right? But since it's squared, it'd be 1 over cosine squared. So we have cosine squared alpha times 1 minus 1 over cosine squared alpha. Right? And then we distribute through, just like what Jasmanian Devil said. So, what's cosine squared alpha times 1? What's cosine squared alpha times 1 over cosine squared alpha? Which is 1. So we got a minus 1 there. Okay? Again, they still want you to reduce this down because they really do want it as like a single idea. So do we know what cosine squared alpha minus 1 really equals? Really, really close to that. But let's take a look at this real quick. So going back to that identity we had a couple seconds ago. Sine squared theta plus cosine squared theta equals 1, right? So we do some manipulation. Well, if we take this 1 and move it over here, we'll get the cosine squared minus 1, right? Because in order to get rid of a plus 1, you got to subtract 1. There you go. So minus 1, and that would be equal to 0 because we moved everybody over to one side. But again, we want this cosine squared alpha minus 1 by itself. So how do we move the sine squared? Subtract it. So it's not the positive that you originally gave me, which was really close. It's a negative. Cosine squared theta minus 1 is really a negative sine squared theta. That's the guy that they're looking for in the end. And again, you can see that on the multiple choice. Because obviously the 1 minus, or the cosine squared minus 1, even though yes, that's in terms of sines and cosines, is not there on your list. Cool beans? Again, we're working with pretty easy stuff here. Most of these you can do sines and, like all of these, you could have just convert everybody to sines and cosines and do some simplifying. A little bit of trig identities that you can use. Oh, speaking of trig identities, we could have done that on this one. Do we know what 1 minus secant squared theta is equal to? Tangent squared. Yeah. So then you'd have negative tangent squared, and you can multiply that by cosine squared, and that would also just jump straight to the end answer. So you could have used that as well. Okay? Again, a lot of this verifying, it's going to be about what you see. So you guys saw changing and canceling to sines and cosines and all that stuff. That's fine. I saw, let's use a Pythagorean identity for secants and tangent, and then I can do some quick canceling. It's all about you see, what you think. All right. So, simplify so that no quotients appear in the final expression. So, we can have it any function we want, just no division though. So, yeah, there we go. So, some people would be like, well, Mr. Armstrong, this is a Pythagorean identity. No, it's not, because it needs to be a plus sign between those two. So that's what breaks that deal. So you can't use any of those Pythagorean identities. We're already in terms of sines and cosines, but Jasmine gave us the key to this one. Remember that when you have addition and subtraction going on in the numerator, you can separate these two out, and they're the two fractions that they are. There is a fraction that has sine squared theta over cosine theta, sine theta, minus another fraction that has cosine squared theta all over cosine theta, sine theta. Separate them into the two fractions, and it's because of that subtraction in the top that we can do that. And now from here, you should start to notice some things. What's going to happen? We can cancel. This sign cancels out with one of the signs that was up above. So that leaves us with sine theta over cosine theta. Minus, what's going to happen with the other guy? Yeah, my cosines will go away. This cosine takes out one of those two that was up above, which leaves us with cosine over sine. And again, the directions say no quotients. So we have to know what is sine over cosine. There you go. Tangent theta And then you supply the other one, which was cotangent theta, because that's what cosine over sine is. And there's your answer. Okay? One more verifying. See, like I said, nothing too crazy. This one should look familiar. So it wants you to subtract these two together and then simplify the result. Subtract these two together, then simplify. Do you remember how to subtract fractions? You got to have a common denominator. What is that common denominator between these two going to be? There you go. It's got to be both of these guys. You need a 1 plus sine x and a 1 minus sine x. You need a 1 plus sine x and a 1 minus sine x. So here's the denominator I have, which is 1 plus sine x. Here's the denominator I want, the 1 plus sine x, 1 minus sine x. So who is the first fraction missing in the denominator? So the top and bottom get multiplied by 1 minus sine x. So what do we get in the numerator here? If I multiply that out, 1 minus sine x. Any questions about what happened so far? Okay. So here's what I have in my denominator right now, 1 minus sine x. I need a 1 plus sine x, 1 minus sine x. So what is this one missing? The 1 plus sine x. So we're going to multiply this guy by the 1 plus sine x. Okay? Fix that guy. So what do I get in the numerator for the second fraction? So now we can actually perform the operation that they want us to, and we can put these together. All you got to do is combine like terms. So 1 plus sine x, 1 minus sine x. What is it that we have in the numerator? What does that all simplify down to? Negative 2 sine x. Because what's going on, you have 1 minus sine x, and then we're subtracting off all of that second numerator. So this negative goes through both of those guys, which changes their signs. So you end up with 1 minus 1, which is 0. The 1s are gone. And then a negative sine x, and another negative sine x, which give us the negative 2 sine x. Because again, the negative changes all those signs over there. And then all it is just combining like terms. Is there anything else that we can do to this? How can we cancel out the sine x? Yeah, we need to distribute the bottom first. We can't cancel this sine x with that sine x because of the addition sign. You can't cancel this sine x with that sine x because of the subtraction sign. Okay? So, but you do need to FOIL this bad boy out. So what happens when I FOIL this bottom guy out? When you do first, outer, inner, last, what do you end up with? You got it. 1 minus sine squared x. Because again, if you do first, outer, inner, last, 1 times 1 is 1. 1 times negative sine x is negative sine x. Sine x times 1 is a positive sine x. So those two guys cancel out. And sine x times a negative sine x is negative sine x squared. Is there anything else we know about this after that foiling then?
1 minus sine x is identity.
1 minus the sine x squared is an identity. Who is that?
It's going to be cosine squared.
Cosine squared. We've talked about that guy before. Because remember, we've got that sine squared x plus cosine squared x equal to 1. If you subtract the sine x to the other side, you see that cosine silly pen. Cosine squared x is equal to 1 minus sine squared x. So we can change this to that. Okay? Is there anything else we can do? Well, all they wanted us to do was do the operation and simplify. That's as simplified as what it gets. So, there you go. And you should be able to find that in one of the multiple choice answers. So, that's also how you know don't go anywhere else. I mean, the other thing that you could have probably talked about is, you could have separated this out. Like, you could have put sine over a cosine and then had another 1 over cosine, which would turn this into negative 2 tangent x secant x. But I'm just letting you know. There is a little bit more that could happen, but since you're looking at your multiple choice answers and we're keeping this relatively simple, dunsies right there. Those are all the 10-1 questions. Those are all the verifying questions. As I told you, we're going to keep it nice and easy for you. Simple stuff. Try not to overthink these, because I know they can be definitely overthought. All right, question 8 starts 10.2. And that will continue all the way through. Looks like 11. Yeah, 10.2 is from question 8 to question 11. Okay. So, 10.2 was all about the sums and differences of angles in trig. So what they're giving you right here is they want you to find me the exact answer of this using sums or differences. So if you try to go straight to your chart and look up sine of 5 pi over 12, you ain't going to see it. Okay, it ain't on there. Which means that this is made up of two of those angles that are on there through addition or subtraction. This is where we break this apart. We find the two angles that we know, and we can work with them from there. Remember in class when we talked about this, if you don't like working with this in radians, what could you do to it? Change it into degrees. Multiply this by 180 over pi, and it makes a number that you can work with a little bit easier instead of trying to deal with fractions. You always have that ability to do that. So if you don't want to work with this as 5 pi over 12, change it into its degrees. Which is what? Anybody figure that out? 75 degrees. So find me two angles that can add to 75 or subtract to 75. And there are lots of different answers. All depends upon what you see and what you want to do. So yes, you could think of this as 75 degrees. If you wanted to. If you're in radians, you multiply it by 180 over pi. So what are our two angles? Pi over 6 and pi over 4, which are what two degrees? 45 and 30, right? And are we adding or subtracting those? Adding to get that 75. So you can talk about this as sine of pi over 6 plus pi over 4. That's one way to think about it. Or you can think about it as this guy was the 30 degrees and the 45 degrees, because that's definitely 75. But there are other angles you could use. Any way that you can get 75 degrees or 5 pi over 12. You can do subtraction for this. There's nothing wrong with that. Okay? There is a way to use subtraction to get to this answer. Any questions so far? But we're not done because we want the exact answer. The reason why we took this 5 pi over 12 and broke it apart into these guys is because we know pi over 6 and we know all the answers for pi over 4. So we go to our formula and we use it. What is the formula for sine plus two angles? All we have to do is fill that information in. You follow me on that? Okay. So sine of pi over 6, cosine pi over 4, plus cosine pi over 6, sine pi over 4. So what is sine pi over 6? 1/2. Okay. What is cosine pi over 4? Radical 2 over 2. Perfect. Plus, what is cosine pi over 6? And what is sine pi over 4? All you do from here now is your algebra skills are going to be tested. We've dealt with the trig. Now it's just all up to algebra. So what's the first thing we want to do to start simplifying? Multiply. Think PEMDAS. Do all your multiplying. So what's 1/2 times radical 2 over 2? Square root of 2 over 4, because you just multiply straight across. Plus, what is radical 3 over 2 times radical 2 over 2? Good, because those two radicals will multiply each other. Radicals can always multiply each other. It's when it comes to adding and subtracting that you got to be careful. So, in the end, I have a common denominator, right? So that means I can put these guys together. What's the denominator going to be? 4. What's the numerator going to be? There you go. Because those two radicals cannot go together because they are not the same. Remember, in order to add and subtract radicals, they have to be the same radical. Like radical 2 and radical 2 could be combined together to get 2 radical 2. But since these are not the same, it's like terms. It's like this is a variable x, that is a variable y. They don't go together. So there's our exact answer. That's what sine of 5 pi over 12 would equal. All right. Numero 9. So here, they've broken it apart for us. We can take this information and we can just put it back together. Although we do know these, this would not be hard to figure out. But I want you to know, the one that you might get on the test, you might not know what these are. They might give you like pi over 12, pi over 12. Okay? So know that if something's broken apart, most likely they want you to put it back together. So who are we dealing with right here? This is sine A plus B? I agree. So this is your sine A plus B. That is the formula that they have written out here for you. All they want you to do is put this back together. So who is our angle A then? Pi over 4. Plus, who is angle B? Pi over 4. Okay? So what do we get when we add pi over 4 and pi over 4? 2 pi over what? Over 4. Don't change your denominator. Don't add the denominators. It's not 8. It's 4. And then what does that reduce to? So sine of pi over 2. That's what I need the answer to. So what is sine of pi over 2? Say it again. You got it. Uno. Okay? Again, we would have gotten the same answer because we know all these guys. Up here, we know what cosine pi over 4 is. We know what sine pi over 4 is. But when it comes to the one that might be on the test, you might not know those. So, in that case, what they really want you to do, put it back together. Okay? Okay. All right. So they want to express this as a single function. So in other words, they want you to apply the formula and do some reducing. Okay? So what is the formula for cosine minus your angles? Let's just get that written down real quick. So we're going to fill this guy in. So, cosine of, who is angle A? 0 degrees. Cosine, who's B? A. It's actually alpha in disguise, but yes, it's fine if you want to call it an A. Alpha. Plus sine of, you said A was 0 degrees. Sine of B, who is alpha. All right. So we're going to simplify as much as we can. So that means we need to know what is cosine 0 degrees. 1. So that's 1 times cosine alpha. Plus, we need to know what is sine of 0 degrees. Times sine alpha. What are we going to end up with in the end? Cosine alpha. Because 0 times the sine will just become 0. So it's like this whole part, we don't care about anymore. So all we're left with is, I drew my alpha symbol first, cosine alpha. That's it. See? One single trig function. That's all they want you to do. Apply the formula. And I know you had some of these in that homework. Everyone good so far? Okay. So, they want you to write the expression as a single trig function or as a single number in exact form. Don't use a calculator. They're trying to trick you on this. They're trying to show you that this is squared, this is squared. Okay? What does a square really mean? There's 2 of those, right? So what this guy really looks like is cosine 45 degrees, cosine 45 degrees minus sine 45 degrees sine 45 degrees. Who is it that we're really looking at here?
Cosine 90 minus sine 90.
Not cosine 90 minus sine 90. This is cosine A plus B. The way this formula is written out, this is cosine A plus B. So they want us to put it back together again. So, who is A? 45 degrees. Plus, who is B? 45 degrees. So all we're really looking at is what? Cosine of 90 degrees. Which is 0. Make sense? They tried to trip you up by combining your two cosines together, which, it makes sense, yeah, because we as mathematicians like to keep things simplified and condensed. But just know that if you have something squared, it just means that you have two of them. Okay? So this really is a cosine, sine, or tangent sum or difference of angles in disguise. They just tried to throw you off. Cool? All right. So that wraps up 10.2. Now we're into 10.3. So these are all about your double angles and half angle formulas. So this runs from 12 and 13 is 10.3. 12 and 13 is 10.3. So again, they want you to write this expression as a single trigonometric function. Okay? So that means we're not going to know the final answer in the end. It's just going to be a trig function. The question is, who did they give us? A over 2. So they gave us the cosine half angle formula. So all we got to do, plug into that. Who is A? 118 degrees. So cosine 118 divided by 2 is what? Done. There's your trig function. It's like what we just did in number 11. It's already broken down for us. They want you to put it back together. Okay? Any questions on that one? Okay, 13. Same idea. Express as a single trig function. Who is this? This is tangent half angle. So this is equal to tangent A over 2. Who is A? You got it. And what is 94 divided by 2? There you go. There is the single trig function. It really is that easy. There is no catch to this. That's what you're doing. And that's 10.3. Just those two questions. Cool beans? Everyone all right? Good. All right. Almost done, guys. And gals. All right, 14. From question 14 to question 19. 14 to 19, these are all 10.4, which is inverse trig. These are all 10.4, which is inverse trig. Make sure that you guys pay attention to those intervals and the domain of these. Because if it's not in the domain, we don't do the inverse. Okay? So, I want to find the exact value of this. So in other words, remember in class, we're looking for when cosine is negative a half. Cosine is negative a half. What is our interval? 0 to pi, which means we're in what quadrants? Quadrants 1 and quadrant 2. Now, before we even begin, I mean, we know that, but the other thing you got to check is negative 1/2 in the domain. Yes, because the domain is from negative 1 to positive 1. Okay? So this is in the domain. That means we can figure this out. So I need to know two angles that are in quadrant 1 and quadrant 2, or maybe one angle, however many there are, that give me cosine equal to negative a half. When is cosine negative a half? But you got to be in quadrant 1 or quadrant 2. In other words, between 0 and pi. 2 pi over 3. There is another angle that's out there, but it is outside our restriction, so you can't use it. This is the only answer that is acceptable. 2 pi over 3. Everyone good so far? Makes sense? Good. All right. Question 15. Same idea. We're just going to keep hitting you up with these questions for like the next, basically for till 19. We're just asking you the same question over and over again. Find me the inverse. Again, don't let the word arctangent throw you off. It means the same thing as inverse tangent. Okay? It means the same thing. So, first things first, what is our range, or what is our interval for this? What's our range? Negative 2 pi. Okay. Negative pi over 2, 2 pi over 2. And what quadrant is that? 1 and 4. Okay, but before we continue on, is negative square root of 3 in the domain? Yes, because what is the domain for these? All reals, means any number will work. So definitely in the domain. So we continue on. Tell me when tangent is negative square root of 3, but it has to be in quadrant 1 and quadrant 4. Negative pi over 3. Now, how did you know it was negative pi over 3? Because someone else would probably give me what angle? 5 pi over 3. Most of you would come up with this first. And if you put this into the computer's going to be like, wrong. Even though, yes, this is in quadrant 4. The reason why it is wrong is because it has to be within our interval. And our interval goes from a positive pi halves to a negative pi halves. So you would need to convert this 5 pi over 3 to its greatest negative coterminal angle, which would be subtracting 2 pi to get you the answer of negative pi over 3. So make sure that you watch your intervals. If you have a negative interval up there, that means you need to take whatever answer is the correct one. If it's going to be in that interval, you might have to subtract 2 pi from it. Might have to do that. So just be careful of that. And I think the ones that you really got to watch that out for is sine and tangent and cosecant. Sine, tangent, and cosecant. Might have to do some of that fancy subtracting. So be careful. 16. So, same question. What's our interval?
Our interval is 0 to pi.
0 to pi. Okay. And what quadrant is that?
1 is 2.
Mm-hmm. Okay, but before you begin, is square root of 3 over 3 in the domain? Yes, because again, the domain is all reals. So we want to know, when is cotangent the square root of 3 over 3? Pi over 3. And again, you would find another one, but it's not in our restricted interval. There is another one, but it's not in there. So you got to throw it out. Okay? Sorry, I put brackets on this. There are no brackets on this guy. Should be parentheses. All right. Did I do that on the last one too? No. Anthony, do you have a question?
Is it important that the parentheses and brackets are different?
Yeah. So, parentheses, yeah. When you have brackets, it means that we can be that number, that value. When you have parentheses, it means you can get really, really close to it, but you can't ever be it. So if my answer in this was pi, I would have to throw that out because pi is not in my interval. I can get really, really close to pi on this interval, but I can't actually be it. Where in the previous question, this one, if my answer was pi, that would be okay for this one because pi is in the interval because of the bracket. Okay? So if you look at 15, notice my interval has parentheses. So if my answer was pi over 2, would I like pi over 2 or not? No, because it's a parenthesis. That's why you see the brackets and parentheses on there. All right, so here, again, we want to know what is the answer. Okay? So first things first, cosecant. What is our interval? But we cannot be 0. Okay? We'll take any number in that interval, but not 0. What quadrant is that? 1 and 4. Question you got to make sure that you answer, first off, is 2 square root of 3 over 3 in the domain? Yes, it is. So all we need to do is find out when is cosecant 2 square root of 3 over 3? Pi over 3. Look on your chart, and it's pi over 3. Do I have to worry about the negative interval on this? No, because it's in quadrant 1. So it's exactly A-okay for this. Any questions here? No. Good. All right. 18. So it says using a calculator. That's a big hint for you. Use a calculator. Okay? Because 4.03 is not on our chart. And this 4.03, is that in radians or is that in degrees? Nope. It's radians. How do I know that? Oh, it wants us to evaluate in degrees, but this is in what? Oh, that's a misprint. That'll be something we need to fix. This should actually have a degree symbol. Because without the degree symbol, that means we're in radians. And that would be really weird. When it's just a number, that means you're in radians. Oh, yeah. Yeah. Never mind. I'm throwing myself off. Yeah, that's just a number. That's the answer to our degree. Yeah. Okay. Never mind. Just a long day. All right, so we're going to go use our calculator. Now, in our calculator, do we have cosecant that we can do? No. So how do we go about, say it again, 1 over sine? So 1 over sine of this, like that? Yes? Okay. Well, what about the inverse? So if we went in here and we put this in, does our calculator like that? Let's take a look. Alpha y equals 1 over sine inverse 4.03, right? Boom. Domain error. That's a problem.
That means undefined.
Does that mean undefined? No. So let's talk about what is really going on here. Okay? Forgot where I'm going. So this is not exactly what we need. That doesn't work. Now let me put it this way. Remember that this is telling us that cosecant is equal to 4.03. About cosine. Cosecant is equal to that. So what could we do to this to fix it? We need something that we can use in our calculator. I like where you guys were going a moment ago. Cosecant is, what's the relationship? It's the reciprocal of sine. But what if I said, tell me this in terms of sine? What would that be? You follow me on that? So cosecant is equal to this. If you want to know what sine equals, you take the reciprocal of it. And then now, what would I do to figure out what theta would be? Or my angle. What would I do to both sides? Inverse sine. So what you need to do for this guy is we want sine negative 1 of 1 over 4.03. Does that make sense? You need the reciprocal of this number. Don't put sine in the bottom. You want the reciprocal of this number because the reciprocal of 4.3 is what sine equals, which allows us to go into our calculator and figure out our answer. Because when you take this and put it in the calculator, it will now work. The other reason why the other one didn't work when we were looking at this guy, remember, this is the answer, right? So it's 4.03 in the domain of sine.
No,
That's why your calculator didn't like it. But when I take the inverse sine of 1 divided by 4.03, this number right there is in the domain. And you hit enter, and we want to be in degrees, so you want to make sure you check your calculator on that guy. So if I hit enter, how many degrees do we got? And what does it say to round to? It says round to 2 decimal places. So what do we get? 14.37. So about 14.37 degrees. Cool beans? Does that make sense? So it's not just that you can take and because cosecant is 1 over sine and you want to make it 1 over sine inverse. You can't do that. You need to take the reciprocal of the number that they give you because that's the answer. It's the reciprocal of that guy. That's who you want to work with in order to take sine inverse of it. So we can use our calculator. Cool? Yeah, just be careful on that guy. And then right here, so they want us to evaluate the expression. So the first thing you're going to do is work inside your parenthesis, then you work to the outside. That's all you got to do. Okay? So inside they want us to do the inverse. So the inverse of cosine, what is our interval? 0 to pi. Okay, and that's quadrants what? Okay, but before we do that, again, is 1/2 in the domain of cosine? Yes, 1/2 is definitely in the domain. So that means we can definitely do this. So what is when is cosine 1/2? Pi over 3. And again, there's another one that's out there, but it will be beyond the range. So now we're looking at, since we know what the inverse is, pi over 3, now they want us to figure out, well, what is cosine of pi thirds? 1/2. That's it. Okay? Cool beans? All right. So you work from the inside out like PEMDAS. All right. Okay. Question 20 through question 23. 20 through 23 is 10.5. And that leaves you 24 through 25, which is 10.6. All right. So here's our interval. So we got to make sure our answers are on this interval. So how do I figure out what x is? What are we going to start doing? Subtract 5. Good. Because what are you trying to do? That's right. Let's isolate our trig function. Treat tangent as if it's one large x and isolate it. So 7 minus 5 is 2. What are we going to do now? Don't subtract 2. Divide by 2. Yeah. Divide by 2, divide by 2. So tangent x is equal to what? 1. Okay? So what do we do now? Take the inverse, right? Inverse tangent on both sides. Tan, -1, tan, -1. So again, we ask, we work with those same questions. But before we take the inverse of this, again, is 1 in the domain? So then that means we can definitely take the inverse of this. So when is tangent 1? And we do not have to worry about the interval that's on there because we've opened up the interval from the very beginning. So when is tangent 1? Pi over 4. And you said 5 pi over 4? Perfect. That's what they want. Okay? And as always with this section, if you question your answers, you can always plug them back in and check them. You can always plug and chug to make sure that, yes, oh, that's really what we got. Okay? All right. So, same thing. Again, our interval, 0 to 2 pi. So, what do we do to start solving this? All right. We break out secant. I wouldn't do that. Yeah, changing things to sines and cosines, you're kind of going to make a mess for us. Set it equal to 0, right? Set this thing equal to 0. That would be a better choice. Let's get everybody on the same side. So how do I move 2 sine x? Minus 2 sine x, minus 2 sine. Well, these two get together, the square root of 3 sine x secant x, will that get together with the negative 2's? No. But they don't disappear, we still write them both down. So now we're equal to 0. Why did you want to set this equal to 0? So that we can factor. Factoring is what you're going to do on this. What kind of factoring are we going to do? Pull out that GCF. What is the GCF in both of these? Sine. Pull sine out. So that will leave us with what? There you go. So now that it's factored, what do I do with all this information? Set them both equal to 0. Okay. So for this first guy, we're going to take sine inverse, right? So we take both sides to the sine inverse. Is 0 in the domain of sine? Yep. So we're good to go. So when is sine 0? Again, we've opened up the interval between 0 and 2 pi. So 0 works. And pi? Okay. So 0 and pi. So what do we do to this guy?
You add 2.
Okay, so add 2.
And then divide by square root of 3.
You got it. And then divide by that square root of 3. Square root of 3. Yep, going to have to rationalize. Go away. So what does secant x equal once we rationalize? 2 radical 3 over 3. Okay. So in order to solve for x, we do what? Take the inverse. So again, we always ask ourselves, is 2 square root of 3 over 3 in the domain for the secant inverse? Yes, it is. So that means we can definitely do the inverse. So x, when is secant 2 square root of 3 over 3? Good. Pi over 6, 11 pi over 6. So we have a total of 4 answers. 0 and pi, and 11 pi over 6, and pi over 6. Cool, cool? All right. So then we got this. Notice our interval, a little different. Our interval's from 0 to 360 degrees. So that means our answers need to be in degrees. Good. All right, so what are we going to do? Yeah, just a GCF again. What's the GCF? 4 tangent squared. Okay. because both numbers can be divided by 4. So what's left? 2 sine theta plus 1. Okay. So what do we do now? Set them equal 0. A lot like what we just did in the previous one. For tangent squared theta equal to 0. 2 sine theta plus 1 equal to 0. Alright, so let's talk about this first guy, tangent. How do I deal with that? Divide by 4? Okay, let's do that. So tangent squared theta equals 0. Now what? Then you got to take the square root, because the only way to get rid of something squared, you take a square root. And usually when you square root both sides, you're going to say that it is plus or minus this value. But does it make sense to have a plus or minus in front of 0? No, because remember, 0 is neutral. It's Swiss. It's neither positive, it's neither negative. So we don't have to worry about the plus or minus in this situation. So then now, how do I figure out what theta is? Inverse of tan. Yeah. Tan negative 1. Tan negative 1. So again, is 0 in the domain of tangent? Or the inverse of tangent? And yes, it is. So we need to know, when is tangent 0? 0 degrees and 180. Okay. Make sense so far? What's going on, Anthony?
Isn't 180
No. 180 is pi. Remember, we're from 0 to 360. Isn't 180 in 0 to 360?
Okay, maybe. Yeah, no, I'm reading paragraphs wrong.
Okay. So then over here, for the next guy, what are we going to do here? Yep. So 2 sine theta equals negative 1 halvesies. So, shoot, negative 1. And then what? Divide by 2. Which gives us negative 1 half. And what are we going to do now? Take the inverse to find it in degrees. Sine negative 1, sine negative 1. So theta is equal to, well again, always check that domain, is negative 1/2 in the domain of the sine inverse. Yes, so that means we can do it. So when is sine negative 1/2? In degrees. 210 degrees and 330 degrees. Any questions on that? Okay. All they did was just make your answers in degrees instead of radians. It's the only difference. All right. Last one for 10-4, or excuse me, 10-5. And this one, it wants all the possible angles, all the possible solutions. And it says, write the angle using the least positive, non-negative angle measure. Okay? It says round approximate answers in degrees to the nearest tenth, if we have to. All right? So notice that, do they want our answer in radians or degrees? They want it in degrees because it says angle measure. And right here it says answers in degrees to the nearest tenth. Okay? So normally in class we said it would be plus 2 pi n. What would we be saying here? Plus 360 n.
Okay, I see that, but it's written in all radians.
Oh. Craziness. Okay. So we'll keep it in radians. That's all right. So no worries. It's multiple choice. So go with what they gave you. But, you know, if you find it in radians and it's supposed to be in degrees, it's an easy switch. All right, what do we do first? What do we got to do? Let's just solve it first before we worry about that angle or the equations. No. We don't subtract the radical 3. Add the radical 3. Add the radical 3. So we got 2 sine x equal to square roots of 3. Divide by 2. So sine x equals radical 3 over 2. And what now? Take the inverse of both sides. Sine -1, sine -1. Real quick question. Is the radical 3 over 2 in the domain? Yes, it is. So that means we can get answers to this. So x is equal to what? When is sine the radical 3 over 2? Pi over 3. Anywhere else? And 2 pi over 3. Because again, we're not restricted by anything now. Okay? So we need to turn these into equations. So what's going to get tacked on to the pi over 3? 2 pi n. Add on 2 pi n, where n, of course, is an integer. 2n pi, all the same. 2 pi n, 2n pi, n 2 pi, all the good stuff. All the same. And then down here, what does that guy get added on with? 2 pi n as well. Cool beans? Everyone good? Last two questions. Last two questions, again, come from 10.6. Last two questions come from 10.6. Look familiar? Very, very closely related to the one that we did in class today. Okay? Remember, there's a long way that you can go about this one. There's a short way you can go about this one. All will get to the right answers. And of course, at the end of this one, we probably want to check the answers. Okay? It's kind of one I made a note of in class that said, hey, you might want to check the answers on this bad boy. All right, so what can we do to start solving this? Start using those half angle identities. We know what these guys are, right? We know what sine x over 2 should be. What should it be? One minus cosine a all over 2. And that should equal, we know what cosine x over 2 should be. Right? And then RA in this case is what, really? X. So we'll just modify that. So what are we going to do now? What are we going to do now? So really what it will do over here is we don't really worry about the positive. We're going to square it. Yeah. Which in the end, does it matter whether that was plus or minus over here? Because it's going to cancel all that information out anywhere. Anytime you square a number, it's always positive. So what are we left with? Okay. Times both sides by 2. Absolutely. clear that fraction out. And that's going to give us 1 minus cosine x equal to 1 plus cosine x. Now what? Subtract 1. And that will leave us with what? Okay? Add cosine? Okay. So we're moving this side over to the other side. So that gives us what? Because we add those two together. 1 cosine plus another cosine is 2 cosines. And then what? Divide by 2. We multiplied by 2 earlier to get rid of the fractions, but now we got to divide by 2. Again. Nope, not yet. So cosine is really equal to 0. And then we take our inverse of both sides. So x is equal to what? But before we do that, is 0 in the domain for the inverse? Yeah, absolutely. So then when is cosine 0? Pi over 2. Okay. But I would always, again, advise you, especially when it comes to 10.6, check those answers. So let's take these two values, and plug it back in and make sure that both of them are okay. So if I come up here, what's pi over 2 divided by 2? Pi over what? Pi over 4. So the question is sine of pi over 4 equal to a negative cosine pi over 4? Is sine of pi over 4 equal to a negative cosine pi over 4? No. Because what you end up with is the sine is a positive square root of 2 over 2. And on the other side, you end up with a negative square root of 2 over 2. So pi over 2 is thrown out. That's a bad answer. Okay? We got to throw that guy out. So now let's check 3 pi over 2. So what do we get when we take half of 3 pi over 2? Three pi over 4. So the question is sine of 3 pi over 4 equal to a negative cosine of 3 pi over 4? Yes. Because sine of 3 pi over 4 is a positive square root of 2 over 2. Cosine of 3 pi over 4 is a negative square root of 2 over 2. But the opposite of a negative is a positive. So it checks out that both of them are equal to each other. So our answer, 3 pi over 2, is the correct one that we want. It's the only one that checks out. Okay? Everyone good on that? All right, one more. So again, we want all exact solutions. Round approximate answers in radians, which obviously it's in radians. Okay, because it's multiple choice. Write using the least positive, non-negative angle measures. All right, how are we going to start solving this?
Subtract negative. Subtract the square root of 3 on the other side.
Nope, don't have to do that. Divide by 2. Get the function by itself. Divide by 2. divide by 2. So sine x over 2 is equal to square root of 3 over 2. So what are we going to do now to figure out what x is? You do the inverse on both sides. So sine inverse is the square root of 3 over 2 in the domain of sine inverse? Yes? So that means we can definitely do this. So that means we have x over 2 equal to, when is sine the square root of 3 over 2? Pi over 3. What's the other guy? 2 pi over 3. Everyone good so far? Okay, but remember, this is the half angle that we're looking at here. I want to know what is the original angle. You got it. I have to multiply both of these guys by 2 to get the x by itself. So what do I get when I take pi over 3 times 2? 2 pi over 3. And what do I get when I take pi over 2 pi over 3 times 2? So there's our angles. These are the guys we want. Now the question is, though, we want all the possible angles. So what is going to get added on to these guys? 4 pi n. Because, again, our original ones, the pi over 3 and the 2 pi over 3 would have had plus 2 pi n. But because we had to multiply by 2, that raises the stakes, which makes this 4 pi n. Because 2 pi n times 2 is 4 pi n. And that is test 2 and what you have to be able to do.